So it's now perpendicular. Okay. That is the electric field that is perpendicular to the surface. Okay, to the surface. And of course, the electric field which is perpendicular to the surface will not change when it pass through, when it get diffracted. When it get diffracted, it will not change the way, the amplitude of the wave. Okay, so the wave will have the same, the refracted one. The electric field will be the same, no changes. Okay, no changes. So these are the E that is perpendicular. So here and here are the same. But the one that is here, the one that get reflected from the surface, will have some changes. Okay, it will have some changes. Well, why? There is a nature. Yeah, the nature of what happened there. So what happened here is the electric field perpendicular to the surface will become smaller. Compare, okay, the electric field will become shorter. Yeah, it becomes shorter. Okay, maybe like this. Okay, become shorter like this. So see, that is the electric field being polarized. So I'll call this one the E prime. Okay, E prime, but it's still perpendicular. Well, how much this electric field becomes shorter depends very much on this angle. So we can adjust the angle to find so that this one reach 0. Okay, so that means it's going to become like this now. Okay, under this condition, we are going to increase the angle. Okay, increase the angle on how light actually enter the surface. Now this angle become larger. Okay, become larger, and the reflected light is still there. Reflected light, of course, because the angle increased, this reflected light is going to have a very large angle also. Sorry, smaller angle here, getting smaller there. So this is our distance for the light. Okay, and the same thing here. This one, of course, no changes. Okay, this one no changes here. So we draw that. The blue one. These are the same lengths. Same lengths. And here. Okay. So our electric field. This is the E perpendicular. This one is the same, no changes, the E perpendicular. But when come to here, the E perpendicular disappear. Okay, the E perpendicular prime become 0. Okay, at a very special angle, and this angle is given by theta p. Okay, theta p, and this theta p is called Brewster angle. Okay, Brewster angle, and it only happen at a specific value, depends on what you have in medium number 1 and medium number 2. So let's assume again, one more thing is the medium number 1 has N1, medium number 2 N2, 1 and N2. So Brewster angle, the tangent of Brewster angle, okay, tangent theta p is given by N2 divided by N1. This is a general equation. Okay, general equation. Okay, so if N1 is 1.00, which is in A, so your Brewster angle formula is given by only N2 only. Okay, N2 only, but this one can only apply if you know that the first medium is A. Alright, so that is our polarization of light based on reflection. Alright, now why is this important? Well, it's not really important to us actually, but it's important to animal that want to see what is down there. For example, eagle. Eagle, the cornea has so many layers that can actually polarize light, because this animal, they are not only can see things that is very far away, like for example, you can see a small chicken, a small chick at a distance about more than 1 kilometer away. You try to do that, you put a small chick at a 1 kilometer away, your stupid eye will see nothing. Okay, not even moving. Okay, so that is what happened when we have this type of reflection, polarization. So the eagle can actually polarize the light, and they can see clearly what is inside the water, like fish and so on. Okay, and that is a source of food. Now, why they are that? Because they evolve. Okay, they evolve. Okay, so they evolve so that they can adapt to the situation like that, so that they can find the food, and because of that they survive. This is Charles Darwin's theory, okay? The survival of the fittest. All right, so that's it for this chapter. Your next video will be on the photon. Okay, so wait for that video.